Okay, so for the first one, for each of these, we've got to pick a variable to solve for because none of them are already solved. For the first one, which variable is easiest to solve for? The x in the second equation. So we're going to do it by simply subtracting 4y. So x equals 3 minus 4y. So we've got that this x equals 3 minus 4y. So this x also has to equal 3 minus 4y. So I'm going to take that equation and replace the x. So 2, instead of times x, it's going to be times 3 minus 4y. Plus 3y equals negative 4. What's next? Times the 2. 2 times 3 is 6. 2 times negative 4. Minus 8y. Still got the plus 3y equals negative 4. And then combine the y. So we've got the 6. What do we have for y? Negative 5y. Negative 8 and positive 3 make negative 5. Then what? Subtract 6. Negative 5y equals negative 10. And then divide by 5. Divide by negative 5. So y equals 2. Now we come back up to one of the original equations. I'm going to use this one actually, the one that I already solved for x. X equals 3 minus 4y. So x equals 3 minus 4 times 2. Yep, I can go back to this one. That's just this equation that's been rearranged. And it's easier because that's already solved for x. I just plug in the numbers to order of operation. I don't have to actually solve anything. So x equals 3 minus 8. So x equals a negative 5. So my solution there is negative 5 comma 2.
See, I put 2 into one of the regular equations.
It should work too. It should still get negative 5.
I got 12. Negative 12.
If you put 2 in here, right? That's 6. Subtract 6 is negative 10. 2x equals negative 10. X should be negative 5. Put 2 in here, that's 8. Subtract 8, it's negative 5. I bet if you put it in here and you subtracted, got negative 10, then you might have subtracted the 2 instead of divided by 2. You get negative 12?
Yeah.
Okay. Over here, which variable and which equation?
No, I got. Oh, I just. Okay.
You figured it out?
I did 2 times 3 and I got 8. That's what.
Ah, okay.
I don't know. I got 8. I subtracted 8. Got negative 12.
Okay, that'll do it. Okay, so over here, which equation and which variable are we solving for? One that makes the most sense is probably to solve for y up here. So 3x minus y equals 10. Subtract 3x. Y equals 10 minus 3x. And, oh, sorry, negative y equals 10 minus 3x. And then divide by negative 1. So that gives us y equals negative 10 plus 3x. So we're going to put that in here for y. 2x plus 3y. Well, instead of y, we're putting in negative 10 plus 3x equals 3. So we got to multiply. The 2x is going to change. We're going to multiply by the 3. 3 times negative 10, negative 30, and 3 times 3x. 9x. And we combine. 2 and 9 make 11x. Minus 30 equals 3. And then add 30. 11x equals 33. And then divide by 11. X equals 3. Then what do we do? Well, I would come up to this equation right here and put in 3 for x. So y equals negative 10 plus 3 times 3. Y equals negative 10 plus 9. Y equals negative 1.
You can always put it in those.
You can put it in one of the originals. It's just easier to use this one because it's already solved.
Yeah.
But you should still get the same answer no matter which one you put it
always
in.
put it in your equation that you solve for,
You can put it into either one of these if you wanted to.
or the equation.
Or the one you solve for, yeah. I always use that one just because it's easier.
Right.
So that gives me 3 comma negative 1. What do you think? Are those coming pretty easily for you? Okay. Not so much? Let's do one more. Give that one a shot quick. This one's a little more difficult because there's no variables that don't have a coefficient on them. They all have something. If I were going to solve for one, I'd probably solve for y, and it really doesn't matter which equation. I'll do the bottom one just because it's a positive instead of a negative. So 3x plus 2y equals 12. What would I do first to solve that for y? I would subtract the 3x. So I now have 2y equals 12 minus 3x. And then divide by the 2. So y equals 12 divided by 2 is 6. 1.5. 1.5 we're going to call it. X. So y equals that. That was this equation here. And I do have to be careful. I have to keep track that this is the equation that I solved. So I have to put it in the other one. If I put it back in the same one, it's just going to disappear. Now, we saw that yesterday. We get some equations where you got just 2 numbers. The variable disappears. If I put it back in here, that's going to happen, and I'm going to falsely think that, oh, this equation is the same line. It's not. So I put it back in the other equation. So that's going to be 5x minus 2, but instead of y, I'm going to put in 6 minus 1.5x. And then we're going to multiply through by the negative 2. Negative 2 times 6. Well, negative 2 times negative 1.5x. 5 is 3x is 4. And then combine 5 and 3 make 8x minus 12 equals 4. And then plus 12. 8x equals 16, and yes, we divide by 8. X equals 2. Now we can come back up here to any of the original equations or the one that we solved here. I'm going to use this one. Y equals 6 minus 1.5 times, instead of x, I'm putting in 2. Y equals 6 minus 1.5 times 2 is 3. And 6 minus 3 is 3, so y equals 3. So solution there is x is 2 when y is 3. How have you had that one? Good. The reason I chose this system the way I did is because it leads us into our next method of solving systems of equations. And hopefully we get the same answer with that method. We've seen when solving equations, like up here, I can add or subtract the same thing to both sides of an equation and it doesn't change it, right? Here I added or subtracted 3x from both sides and it didn't change it. So what I want to do down here is I want to take this top equation and I want to subtract. I'm going to write it over here. In fact, I'm not even going to subtract. What I'm going to do is I'm going to actually add 12 to both sides. But now here's the thing. We've seen that you can substitute, right? Up here, because y equaled 6 minus 1.5x, I was able to put that in here and replace that y. I'm going to do the same thing here. Instead of adding 12 on this side, I'm going to replace it with, because 12 equals 3x plus 2y. Does that make sense? So what I'm doing is I'm adding 12 to both sides. But on this side, I replaced the 12 with 3x plus 2y. So now I can add. Well, 4 plus 12 is 16. On this side, I can only combine the things with the same name. So 5x and 3x make 8x. Negative 2y and positive 2y, 0. They disappear. It's gone. I got rid of one of the variables. This method is what we call, depending on the textbook, some textbooks call it elimination, which is fitting because I eliminated one of the variables, or addition. And what it's saying is, and it's for the very reason I just said right here, I'm adding the same thing to both sides. The 12 and the 3x plus 2y are the same thing. I'm adding the same thing to both sides. But what the elimination or addition method is saying is, as long as it's lined up with my x variables, my y variables, my equal sign, and then my constants, or my numbers, or whatever. As long as it's lined up like that, I can just add down the columns like I did right here. And here, the y disappeared. So I can solve for x. Divide by 8. X equals 2, which is what we got up above. To me, that's a lot simpler than substitution. Now, the payoff is I got to put that back into one of the original equations. And I don't have an equation that's already solved, so it's going to be a little bit more work. So I'm going to put x equals 2 in here. So 3 times x becomes 3 times 2 plus 2y equals 12. I can put it in the top one. I can put it in either one. It doesn't matter. 3 times 2 is 6 plus 2y equals 12. The only reason I chose the bottom one is because there's a negative up there, and negatives tend to confuse people, so I avoid it. So I'm going to subtract 6. 2y equals 6. And divide by 2. So y equals 3. Now, what if I had chosen the top one to use? So 5x minus 2y equals 4. Well, 5x becomes 5 times 2 minus 2y equals 4. 10 minus 2y equals 4. Subtract 10. Negative 2y equals negative 6. Divide by negative 2. Y still equals 3. So my solution here, again, is x equals 2, y equals 3. Same solution we got with substitution. I think the elimination or addition method is a lot simpler to do in most cases than substitution. It's a lot less variable manipulation. It is easier, but you will notice there was something very special about this system of equations that made it easier. What was it? when I added down the columns, there's one variable that's going to disappear because it's a negative 2y and a positive 2y. It's not always going to be the case. How about something like this? If I just add, is it lined up, first of all my x's, my y's, my equal sign, and then my constants? Is it lined up? Yeah, it is. If I add down those columns, is either variable going to disappear? No, it's not. But I can do this. Why would I multiply that bottom equation by negative 3? Yeah, then what I'll have, the top equation is still going to be 3x minus 2y equals 16. This one's going to be negative 3 times x is negative 3x. Negative 3 times 3y is negative 9y equals negative 3 times negative 13 is a positive 39. 3x and negative 3x cancels out. Negative 2 and negative 9 is negative 11y. Equals, is that 55? And now I can divide by negative 11. Y equals negative 5. So then I have to put that back into one of these for y. I'm going to use the bottom one. X equals 3 times negative 5, or x plus 3 times negative 5 equals negative 13. 3 times negative 5 is a negative 15. And we add 15. X equals 2. So the solution to this system is x is 2, y is negative 5.
You're just able to multiply
The whole equation?
opposite of 3?
Yeah.
Because the 3 was in the top equation?
Yep. Yeah, because by multiplying by negative 3, that tells me the bottom one's not going to be a negative 3 and they'll cancel out. Sometimes you can't just multiply one equation. Sometimes you're going to have to multiply both. We might have...
This is only for this method, right?
Yeah, this is only for elimination or addition. Something like this. What you got to think of is kind of like common denominators, which you actually think of as common multiples. Again, first of all, it is lined up. I've got my x's, got my y's, got my equal sign, got my numbers, my constants over here. So it is lined up. That's the first thing I have to make sure of. But now I'm going to think in terms of common denominators, least common multiples. For x, I've got 5 and 2. The least common multiple there would be 10. So I could take those both to 10s. For y, I've got 2 and 3, and I'm going to ignore the fact that that's negative. 2 and 3, the least common multiple will be 6. I think I'm going to go for the y's. Get rid of the y's. So if I multiply the top by, what do I want to do? I want to turn that into a 6. What do I have to multiply by? 3. Multiply the bottom one by 2. Now, I'm going to pause here for a second and make a side note. 3 times negative 2 will make a negative 6. 2 times 3 will make a positive 6. What if this had been a negative 2 up here? What would I have to do? Or a positive 2 up here instead of a negative 2? Yeah, one of them would have to be negative. It doesn't matter which one, but I'd have to make sure one of them is going to be negative when I'm done. So on top here, 3 times 5 is 15x. 3 times negative 2y, negative 6y. Equals, and don't forget, this is the part that most people will miss, is you got to multiply the constant. 3 times 1 is 3. 2 times 2x is 4x. 2 times 3y is positive 6y. Equals 2 times negative 11 is a negative 22. $15x and 4x make 19x. Negative 6 and 6y cancel out. Equals 3 and negative 22 is a negative 19. We divide by 19. X equals negative 1. Now I put that negative 1 back in either one of the original equations. It does not matter. I'll use the bottom one here. So 2 times x becomes 2 times negative 1 plus 3y equals negative 11. And 2 times negative 1 is a negative 2 plus 3y equals negative 11. Adding 2 to get rid of the negative 2. 3y equals negative 9. And divided by 3. Y equals negative 3. Negative 1, negative 3. We will practice these more tomorrow. Actually, you know what? No, we won't. We'll practice these more Tuesday. Tomorrow I'm going to be gone during this class for an appointment. I got an 8 o'clock appointment tomorrow morning. So we'll practice these more on Tuesday. No math at all tomorrow. I won't be back until like 9, and I'm not making you guys come for the last 20 minutes. You guys get to sleep in tomorrow? Is that what you're saying?
Oh my god. It's like a little vacation.
You don't dare miss print reading. So, yeah, so page 413 and 415, it's exercise 17-3A and 17-3B.